Okay, chemistry students, this is Mr. Azentis and I'm on chapter 8, and what we're talking about is molecular shapes. Alright, and I have a grid here. I don't know if you could read it. This is molecular formula, electron total, Lewis dot, bonds around the central atom, molecular geometry, and bond angle or bond angles. So the first molecular formula I'd like to work on is CF4. Now if we count up the total number of electrons in this molecule, CF4, C, we know if we look on our periodic table, it's got 1, 2, 3, 5 electrons in its outermost shell. F has 7 in its outermost shell. 7 times 4 plus 5 is 32 electrons total. So if we put our Lewis dot together, we're going to have C. We're going to have and the fluorine is going to share, but that's filled as well because it wants to be satisfied. So these are filled as well, and if we counted all of these electrons up, what we would find is that we have a total of 32. Now, how many bonds are there about the central atom? Bonds around the central atom. Well, we've got 1, 2, 3, 4 bonds around the central atom, and we have how many lone pairs? 0 lone pairs. So with that arrangement, if we have four bonds around the central atom and 0 lone pairs, we have 4 bonds around the central atom, and there's 0 lone pairs. Then the arrangement is tetrahedral, and that's just something that we're going to have to remember or look on our grid. It's tetrahedral, and tetrahedral, if you recall, is a shape that looks, well, something like this, and we have bond angles of 109.5. Now the next one is SF4, and these are 7 times 4, and sulfur's got 6, so we have a total of 34 electrons, and our central atom is the sulfur, and we've got 4 fluorines around it. The sulfur has got 6. 1, 2, 3, 4, 5, 6. So what's going to happen here? These electrons will want to stay together, but these 2 electrons will share with these 4 fluorines here. And so when they share with these 4 fluorines of course are completely filled, and if we counted up all of our electrons, then we would find that there's 34, and we have 1 lone pair. So we have a total of 1, 2, 3, 4, 5 is the steric number, or the total number of bonds around our central element. And with 5 and 1 lone pair of electrons, we look on our grid, or we just try and put to memory that if you have 5 with 1 lone pair, it's seesaw shaped. And this grid I could give you. It's available online. It's also I put it together in class for you. But the shape is seesaw shape, and with a seesaw shape, you're going to have a central atom here, 1 sticking out at either end, a lone pair that's pushing these two groups, 1 sticking out and then 1 going back in. So it kind of looks like a seesaw. This bond angle here on the seesaw is going to be 120. Of course, this is 180, and we also have this bond angle, which is 90 degrees. All right. So the next one is PF5 for a total of 40 electrons. you'll have to count them up. We've got 5 for the phosphorus, and the fluorines have 7 each. 7 times 5 plus, so that's 35, plus 5 is 40, and we have phosphorus is in the middle with 5 electrons. 5 electrons conveniently want to share with the fluorines. Fluorines are all filled up. These fluorines are all filled up, and they also are sharing these electrons here. And so we have 1, 2, 3, 4, 5, 0 lone pairs. And with 5 with 0 lone pairs, we look on our grid, we'll get a trigonal bipyramidal shape. And with the trigonal bipyramidal shape, if you recall, that shape looks like a triangle. That's the trigonal part, and then one sticking up and one coming down. And we have the angles within these triangles is going to be 120, but of course these two is going to be 180 as well. So those are our bond angles. So trigonal bipyramidal, you just have to remember that shape. I apologize about my drawing, and the angles you'll have to remember as well. So another is SO3. We have 24 total electrons, and the way I count that is 6. We have 6 for the sulfur, and we have 6 for the sulfur, and then the oxygen has 6 as well. So we have a total of 6 times 4 is 24. So the central atom is sulfur. Now in this situation, the sulfur with 6 electrons, about its central. Now in this situation, the oxygen also has 6, and so 1, 2, 3, 4, 5, 6. So we'll have to have an electron come over and share. It will have 2 electrons shared here, and then we have 1, 2, 3, 4, 5, 6. 2 electrons come over and share here, right? And then we have this oxygen up here. I'm kind of running out of space. We have, remember, we still have this. We still have 2 here. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, but we need a total of 8 around here in order for it to be satisfied. So in order for that to happen, what'll happen is we'll have to have a double bond here. So 1, 2, 3, 4, 5, 6, 7, 8. And so that would be 8 times 3 here. So let's see, did we satisfy 8 times 3 is 24, 6? Yeah. All right. So we have 3 with 0 lone pairs, and with 3 bonds and 0 lone pairs, we're going to have a trigonal planar. Alright, trigonal planar, and so it's all in one plane, and one of them is a double bond, and they come to think of it, that's a T shape. My apologies. They'll be equally spaced, won't they? Yeah, I'm sorry. They'll be equally spaced with bond angles of 120. All right. Another we could do is BRF3 with a total of 28 electrons. BR contributes 7 plus, so it's basically 7 times 4 is 28, and so the BR it has 7 electrons. 1, 2, 3, 4, 5, 6, 7, and these 3 will share with these Fs. So these are saturated with electrons. Let me fill these. And in this situation we have two lone pairs. We have two lone pairs with a total of 5 bonds about the steric number of 5, or 5 bonds about that central atom, two of which are lone pairs. Then what we have is by definition a T shape, because in this situation you'll have, here's our central, and then you have these lone pairs. Now here's our lone pair sticking up, and it makes this T shape. And so this is going to be 180 degrees, and these of course are going to be 90-degree angles here, as you can see. Alright, now let's take a look at a couple more. We have molecular formula, we have electron total, Lewis dot, bonds about the central atom, our steric number, molecular geometry, and then bond angles. So let's try another SF6. Sulfur has 6 electrons about, and then fluorine has 7. So 7 times 6 plus 6 basically, and that's going to be a total of 48 electrons. Now we have to account for those 48 electrons in our Lewis dot structure. Sulfur, as we said, has 6 electrons about its central. 1, 2, 3, 4, 5, 6. Well, that's going to be convenient because each one's going to share with the fluorine. Alright? Now, each one will share an electron and make a bond, and each one of these is saturated. So we have 8 electrons around each one of these fluorines, and they're also sharing with the sulfur. So something like this. And then so we count up the number of bonds about that central atom. We 1, 2, 3, 4, 5, 6 around the central atom, and we have 0 lone pairs. And with that arrangement, we make what's called an octahedral. And the octahedral, as we've said in class, has this shape that's basically a square, and this square then has one electron bond, shared bond above and one shared below, and so we have this basic eight-sided structure called an octahedral. And this one, of course, is these two up and down are going to have a bond angle of 180, but these all, because it's a square, are all going to have 90. So 180 and 90 degrees are our bond angles. The next we could try is BRF5, and BRF5 has 42 electrons. Bromine has 7, fluorine has 7, so it's basically 7. We have 7, 5, 6, so it's basically 7 times 6, right? And that's 42. So we have bromine in the middle with 1, 2, 3, 4, 5, 6, 7. So what'll happen is these electrons are together in a pair and stable, but the rest of them will share with the fluorines. And so we have this unpaired here, but the rest of these fluorines are going to have a full octet. So let me fill these octets, and now we have a total of 1, 2, 3, 4, 5, 6 bonds with one lone pair. And with this arrangement, it's basically the octahedral, but instead we have a lone pair down here. And so in that situation we have what's called a square pyramid. Alright, and so we have here's this square coming out, central atom, and then one coming straight up. So that's the square pyramid, and then down here on the bottom we have our lone pair pushing those up. And so all these angles are going to be 90 degrees. Alright? So maybe we have time for one last one. NH3 is going to be a total of 8 electrons. We have N in the middle, and the hydrogen here, and then a lone pair of electrons here. So we have 3. Steric number is 4 with 1 lone pair, and we have a geometry which would be described as pyramidal. Now we could be more clear and call this trigonal pyramidal, because you could have square pyramidal as well. This is just but we have 1, 2, 3, and then so this is the pyramidal, and then we have a lone pair at the top. So it kind of makes a little pyramid, and all of the angles are 120 degrees.